Okay, so 2.5, gonna have some proving statements with segments and angles. So we're gonna start into this world of what's called proofs, and it is probably the hardest thing that we do. So if we had this picture, and it's going to tell us, it always tells you some stuff. It's going to say something's true no matter what. You don't have to know why, it just is. It's called given. So the given is that measure of angle 1 equals the measure of angle 3. So I always look at the given, and most of the time it is marked in the picture, but if it's not, I like to mark the picture, okay, those two angles are equal or those two angles are congruent. And sometimes it might give you more than one thing given, and that's fine. Excuse me. So we're going to prove that measure of angle DBA is equal to the measure of angle EBC. So some of your problems today for proofs are going to be what's called fill in the blank. So you won't have to create a proof from scratch. You'll have like blanks just to fill in, and then you'll have two at the end that you will have to do this all by yourself, or create it from the beginning. So when we do a 2-column proof, we have statements on one side and reasons on the other. Now, reasons can be a bunch of stuff. It can be definitions, properties. We haven't talked a lot about them, but theorems, postulates, those are the main things that we put over there. But the first step to any proof is to just write down the given. And the reason that measure angle 1 equals measure angle 3, how do I know that? Well, it was given. So that's the reason for that first thing. Okay, now I have to kind of get creative a little bit and figure out how can I need to end up with DBA and EBC, the proof part, at the end. So I have to introduce DBA. Well, what's DBA is angles 2 and 3 combined. You see that? DBA is from there over to there. Okay, so here's where angle addition postulate. I can say that the measure of angle DBA equals the measure of angle, I should have put this over farther, measure angle 2 plus measure angle 3. So this was given, and see, this is angle addition postulate. So there I got angle DBA into the problem. So I need to do the same thing for EBC. Oh, that up top I put an F and it should have been an E. So EBC is the green part. So it's 1 and 2 together. So measure angle EBC equals the measure of angle 1 plus the measure of angle 2. And that is also, and you can abbreviate, angle addition. So in the end, I need to say that that and that are equal. Okay, so here's where one of the so it's like, what else do I know? So here's where some of the other properties come into play. 1 and 3 are the same. So I can substitute in one of, anywhere I see an angle 1, I could put a 3, or anywhere there's a 3, I could put a 1. So I'm going to do this 1 right here, I'm going to make a 3. So if I say measure angle EBC equals the measure of angle 3 plus the measure of angle 2. And why am I allowed to do that? The substitution property. I replaced one thing for another thing that's equal. So what I've just created is, if you look at, there's a 2 plus 3, and there's a 2 plus 3, or a 3 plus 2, it's the same thing. So those two things are the same. So if those two yellow things are the same, then that one and that one, oh, I didn't put a C right there, needs to be the same. So I can say measure angle DBA equals the measure angle EBC. And, well, if DBA is 2 plus 3 and EBC is 2 plus 3, then those two things are equal. That is transitive property. Or I would accept substitution. It does make sense to me. So sometimes when you put transitive property, you can write substitution. But when you're supposed to write substitution, you cannot write transitive property. So it's kind of a different thing. Like the step above where it says substitution property, you could not put transitive right there. It doesn't make sense. But the bottom one, it does make sense. Okay, so not easy stuff by any stretch. Okay. All right, so let's look at another one. So let's first, here's kind of some steps to writing a proof. So we're going to write the given, and then we're going to make conclusions about the given. And sometimes you can do that, sometimes you can't. It just depends on what it says. So I'll give you a little hint on today's assignment. So if it says something bisects, okay, so it's going to cut in half. Okay, so if, let's just say that we had ABC like that, and it said that, let's just say this is like line M bisects AC. So if that was in the given, it said line M bisects segment AC, then your conclusion that you can make is that AB is congruent to BC. Okay, because it bisects, it cuts it in half. And you'll be able to use that information, or you'll need to use that information later on in the problem. Okay, so one of the problems that you have to come up with information on your own in the given, it's going to say that something bisects. So you're going to, in the next statement that you can put is that, you know, whatever it bisects, like this equals this, or this is congruent to this. Okay. So then you're going to use properties, postulates, definitions. So you're going to have to look at the picture and say, well, I can use this property, I can use this. So all the properties and the postulates and the definitions that we've talked about so far are all fair game. Okay? So you may have to use more than one. And then if you've done all that, you should be at the prove statement, which is like the last statement of the proof. Okay, these take practice, these take trial and error. So I don't expect you to be perfect after just today, but gotta work at it. So let's look at another one. So if we have E over here, F, H, and G. So it's going to say given angle GFH is congruent to angle GHF. Prove angle EFG and angle GHF supplementary. All right, so first thing, write the given. Angle GFH is congruent to angle GHF, and I know that because it's given. So label that GFH, that one, and GHF, that one, are congruent. Okay, and then I want to say, so this is sometimes just to help you kind of visualize EFG. So I want to say that angle 1, I just made up my own like label, and GHF, I want to say that those two are supplementary. And if they're supplementary, that means they add up to 180. So I'm probably going to need to have somewhere in the problem that some angles add up to 180. So sometimes just looking at like, well, how could I make an argument that that is true is good just in speaking, and then how do I write that down? Well, if angle 1 and GFH, the one here with the red that I just marked over in black, I'll put it back in red, but those two are a linear pair because they make a line, and a linear pair is supplementary. So if those two are supplementary and the two red ones are equal, then I could substitute somehow to make angle 1 and angle 2 supplementary. Okay, so these number 1 and the other red one form that linear pair, therefore they're supplementary. So if they're supplementary and the two red angles are congruent, I could substitute to make them the 1 and 2 be supplementary, which is what I want. So I said a lot there. Okay, the first thing I said was angle EFG, that's the angle 1 that I wrote up there, and angle GFH are a linear pair. Now this is kind of a different, like, how do I know they're a linear pair? We're allowed to say it's in the diagram. It's another way of saying given. It's in the picture. I'm allowed to say that. So if they're a linear pair, then angle EFG and angle GFH are supplementary. And that is, why am I allowed to say that? That's the definition of a linear pair. And if they are supplementary, then I can say that angle EFG plus angle GFH equals 180 degrees. Definition, supplementary angles. Okay, so why did I do all that? Well, it goes back to statement number 1. GFH and GHF are congruent, or they're equal. So in the end, if we go over to the prove part, I want to say that EFG, which is right here, and GHF are supplementary. But I have GFH. So see, I can substitute, because back at this first step, I can take this and I can substitute it right there because they are congruent, or they are equal. So I can say that angle EFG plus angle GHF equal 180, and that's substitution. And then if they add up to 180, I can say EFG and angle GHF are supplementary. And that again is definition of supplementary angles. So supplementary angles, you can say that they add up to 180, or if they add up to 180, they are supplementary. You can go back and forth. Okay? So you're not going to have very many problems to do today. You'll have 2 fill in the blanks. And then you'll have some more just what property is this, and they list the properties in the section already for you. So if you kind of in your book, if you page back from the page where the problems are, you'll have the properties listed again: reflexive, symmetric, transitive. Some of the other ones aren't listed there, but like the substitution and things like that. So so remember, you will have on one of the proofs that you have to do on your own. Let me give you some hints. So you're going to have to use bisect. I talked about that. You're going to, that they cut each other in half, so both sides are the same. You're going to have to use segment addition. And you'll have to use substitution. And you'll probably need to use transitive property. Okay, so on that last one, you're going to have to use the informations. On one of the other ones, you're going to have to use, it's the fill in the blank, but you're going to have to use the definition that complementary angles add up to equal 90 degrees. Okay, it doesn't mean that like there aren't, there's some segment addition in the other ones, but okay, give it a try. We need to ask questions tomorrow if you don't understand. Okay, this is not an easy concept, and it takes some time to get better at it. So, but not that many problems today. I think 9 problems, 8 problems, something like that. So, all right, good luck, guys. Give it your best shot. We'll see you tomorrow.